Today we will discuss assignment problem. Suppose there are n jobs to be performed and n persons are available for doing these jobs. Let Cij be the cost if the ith person is assigned to the jth job. The problem is to find an assignment. Which job should be assigned to which person on a one-to-one basis so that total cost of performing all the job is minimum. Problems of this kind are known as assignment problem. For example, you can see persons 1, 2, 3, etc. up to n, job 1, 2, 3, etc. up to n. N we are taking generally, you can take it as 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. In assignment problem, the number of rows should be equal to number of columns. That is, number of persons should be equal to number of jobs to be assigned. So C11 means the cost of doing job 1 by the person 1. C22 the cost of doing the job 2 by the person 2. Similarly C23 the cost of job doing the job 2 by the person 3. Similarly etc. as like Cn3 the cost of doing n the jobs by the third person. There are two types of assignment problem. It is generally assignment problem is classified into two. One is balanced assignment problem and unbalanced assignment problem. If the number of rows brackets or jobs is equal to the number of columns or operators, then the problem is termed as balanced. Otherwise, number of rows is not equal to number of columns. It is known as unbalanced assignment problem. If the problem is unbalanced, then necessary number of dummy rows and columns with a zero costs are added in such a way that the correspondence should be a square matrix. In doing assignment problem, a special method known as Hungarian method is used. This method has two phases. In the first phase, row reductions and column reductions are carried out. In the second phase, the solution is optimized on iterative basis. For example, solve the following assignment problem. Here there are 1, 2, 3, 4, 5 operators and 1, 2, 3, 4, 5 jobs. So first of all, before doing the problem, we check whether number of rows is equal to number of columns. Here in this case, number of jobs is equal to number of operators. Both are 5, which are same, so it is a balanced transportation problem. So we can directly proceed with the Hungarian method. In the phase 1, row reduction. Row reduction means subtracting the minimum value from each row of the cost matrix. So the first case, the minimum value is 8. We have to subtract 8 from each element. 10 minus 8, 2. 12 minus 8, 4. 15 minus 8, 7. 12 minus 8, 4. 8 minus 8, 0. Similarly, in the second row, the lowest element is 7. We have to subtract 7 from each value. Here the lowest value is 7 again. We have to subtract 7 from each value. So here the last row, the minimum value is 8. So 8 minus 8, 0. 13 minus 8, 5. 15 minus 8, 7. 11 minus 8, 3. And 15 minus 8, 7. Then the second step 2, that is column reduction. Column reduction means subtracting the minimum value from each column from the above matrix. So the first row, first column you can see that the minimum value is 0. Here on 0 is here. So we have to subtract 0 from all the values. That means the column will be same. There is no change in the elements of the cost in the column number 1. Second column also minimum value is 0. That is 4 minus 0, 4. 9 minus 0, 9, 7 minus 0, 7, 0 minus 0, 0, 5 minus 0, 5. Here also the minimum value is 0, so subtract the same value. The fourth column, you can see that the minimum value is 2. We have to subtract 4 minus 2, 2, 7 minus 2, 5, 2 minus 2, 0, 3 minus 2, 1, and 3 minus 2, 1. Here also 0, the same value will be repeating. So you can see this here, that is 2, 4, 0. Then optimization, the phase 2, we are going to do the optimization of the problem. Optimization means draw a minimum number of lines to cover all the zeros of the matrix. For doing this, we have the following steps. The first step is known as 3.1 row scanning. Row scanning means we are checking, the question we are asking, is there exactly 1 0 in that row? So you can see that in the first row there is only 1 0. We block with a square and we have to vertically cut that column, not row. The second row there is only 1 0 here, exactly 1 0 here. We block with a square and vertically cut the first column. The third row there are 2 zeros, we have to skip that row. The fourth row, after cutting this the last two column, remaining is only 1 0. This is that exactly 1 0, 1 0 is here. We have to block with a square and vertically cut the second column. In the fourth row there is no zeros, we can't do anything. The next step is to check all the zeros are covered with the lines. Here 0 0 is remaining in the third row, that is all zeros are not covered with the lines, so we have to proceed with the column scanning. Column scanning means we take the first column and check is there exactly 1 0 in that column. So after row scanning, the vertical cuttings are like that. We have to do the column operation in the same matrix. Take the first column, already cut, nothing we can do. Second also already cut, we can't do anything. In the third column, there is only 1 0. We block with 0, we horizontally cut that row. Then fourth column, then is there exactly, because already we cut the third row, it already cut, nothing we have to do. Then we have to check all the zeros are covered with the lines. Here all the zeros are covered with the lines. The next step is we have to check the number of squares marked is equal to number of rows. The squares marked is 1, 2, 3, 4, but number of rows 1, 2, 3, 4, so it is not equal. So optimization is not reached. Then the next step is identify the minimum value of the undeleted cell value. Here you can see that undeleted cell value 727511. The minimum value of these undeleted cell value is 1. The next matrix is formed by adding 1 to the intersection points and keep all the deleted values keep it the same, and the remaining undeleted cell values we have to subtract the minimum value. So the next matrix is like this: 2, 0, 6, 6 plus 1, because its intersection point 6 plus 1, 7, 2, 0. Here 4, 9, 7 plus 1, 8, 0, 5. Here it is an undeleted value, we have to subtract 1, this becomes 6, 6, nothing we have to do, 0, 0, and 7 minus 1, 6. Here 2 minus 1, 1, 5 minus 1, 4, 0, 0, 0. Here 0, 4, 2, its intersection point, 2 plus 1, 3, 0, and 7. This is the matrix after the minimum value, deleting and adding and subtracting the values. Then again do row scanning. We have to check is there exactly 1 0 in that row. Let's take the first row. Here only is 1 0. We vertically cut. Here also 1 0. We vertically cut. And the third row, there are 2 zeros. Nothing we can do. The fourth row, Fourth row, nothing we can do. In the fifth row, after cutting this, only one, so it is here to this block with the square. Now we check all the zeros are covered with the lines. So we do the column scanning. After the column scanning, you can see that all the zeros are covered with the lines. And we have to check the number of squares marked. 1, 2, 3, 4, 5 is equal to number of rows. Optimization is reached. So we take job 1. You can see that square mark is 5. That is here this job. Job 1 should be done by the fifth person. That is 1 to 5. The time you can give in the age. The second 2 to 1. Third 3 to 3. And 4 to 2. And 5 to 4. So total time duration is 43. Take another example. Operate 5 and 5. The same procedure. First of all, row reduction. That is here to subtract the minimum value from each row. We get this matrix. Second row also, third, fourth, and fifth. Then column reduction. We have to subtract minimum value from each column. We get the matrix as 29089, 21306, and 40213. The next step is phase 2. That is the row scanning. That means first question, take the first row. We are asking, is there exactly 1 0 in that row? Yes, if it is that, you have to switch the square and vertically cut. And second, also you have to take vertically cut. And third, also we take it is and vertically cut. And the third row, nothing we can do. Already we cut. So, and the fourth row, nothing. And fifth row, only 1 0. We have to the vertically cut. We now look at all zeros are covered with the lines. So here you can see that all zeros covered with the lines. There is no need of column scanning. So now next step is we have to check the number of zeros marked is equal to number of zeros. So it is not equal because 1, 2, 3, 4, but number of rows is 4, 5. So optimization is not reached. As before, we take the minimum value and subtracting 1 from all undeleted cell values and adding 1 to the intersection points, and all deleted value keep it as same. So after doing this, we do the row scanning. First 0 we mark with the square and vertically cut. Second also vertically cut, and nothing in the third and fourth row. We take it to the last row, only 1 0. You have to mark with the square. Here also next step is you have to check all the zeros are not covered with the lines. So there are 2 zeros are remaining. So we have to do column scanning. If all zeros are covered with it, there is no need of column scanning. But in this case, 2 zeros are remaining. We have to do the column scanning. Column scanning, after this we square this and vertically cut. And the fifth row, nothing we can do. So check the number of rows squares marked 1, 2, 3, 4 is not equal to number of rows. So optimality is not reached. So take the minimum value. Here the minimum value here it is 2, 2, 2, 3, 4, 2, 5, 8. The minimum value is 2. We have to subtract 2 from all the values, undeleted values, the zeros. We get 19087, 11304, 05410, 27011, 30211. Now next step is row scanning. Is there exactly 1 0? Here is only 1 0. And we with the square and vertically cut. Here only 1 0 and vertically cut. And here are 2 zeros, nothing we can do. Here is only 1 0 and vertically cut. And here also 1 0 vertically cut. So you can see that all zeros are not covered with the lines. Then column scanning we get only third row we can vertically cut. So then you have to check the number of squares marked 1, 2, 3, 4 is not equal to number of rows. We take the minimum value. Here minimum value is 1. We subtract and all the values, and after row scanning and column scanning we get the assignment is like this. First row closed, second row, third, 1, 2, 3, 4, 5 is equal to number of rows. So optimization is reached. First job should be done by the first man, second job should be done by the fourth person, and third should be done by the fifth person, and fourth should be done by the second person, and fifth should be done by the second person. Example 3, solve the following assignment problem. So there are 5 rows and 5 columns. As before, you can proceed. The answer is row reduction and column reduction. After that, phase 2, that is, here also we noted the number of rows is equal to number of columns. We can directly go to the Hungarian method. Then optimization. So is there a scanning? That is there actually 1 0 in the first row? Only 1 0 here, vertically cut. Second row also 1 0, vertically cut. Third also in the 1 0, vertically cut. Then fourth and fifth are not, there are 2 0, nothing we can do. So here we can see that all zeros are not covered here. 0 is here, 0 is here. So we can go directly to optimization. We can't check whether this number of rows is equal to number of squares marked. So because 2 zeros are remaining, now we have to do the column scanning. So in column scanning, you can see that vertically cut, horizontally cut. Then here you can see that all zeros are covered with the lines. Next step is you have to check the number of squares marked 1, 2, 3, 4, but not equal to number of rows. So optimization is not reached. Take the minimum value from the undeleted values 3, 2, 3, 4, 3, 2, 2. So minimum value is 2. So we have to subtract 2 from all the undeleted values, and intersection we have to add 2, and all deleted values keep it as same. So the next matrix come like that. Then first scanning the first row, nothing we can do. Second row 1 0 is here, vertically cut. Third 1 0 is there, vertically cut, and the fourth vertically cut. So here also you can see that 2 zeros are remaining. So we can't avoid column scanning because 2 zeros are remaining. So we are doing the column scanning. After the column scanning, in the same repeated again, the same matrix we are using after the row scanning. So already there it is first column cutting, second column is because after completing the row scanning, we are proceeding the same matrix. Then we take the third, you can see that only 1 0 is there, vertically cut. Then check all the zeros are covered with the lines, but number of zeros marked 1, 2, 3, 4 is not equal to the number of rows. We take the minimum value is 1, and subtracting minimum value from all, and after that we are doing this cross scanning. 1 0 is there, it's vertically cut. Second 0 is vertically cut. Third nothing, 2 zeros are there. Here the fourth row, after cutting this, only 1 0 is here, so vertically cut. And fifth row, nothing we can do. So you can see that all zeros are not covered with the lines. So we are doing column scanning. After the column scanning, we can see that all zeros are covered with the lines. So next step is you have to check number of zero squares. 1, 2, 3, 4, 5 is equal to number of rows 1, 2, 3, 4, 5. Optimization is reached. So first job should be with the second person. Second job should be done with the third person. Third job should be done with the third person. And fourth job should be the fifth person. And fifth job should be done by the first person. Then another example. Operator 1, 2, 3, 4, 5, 1, 2, 3. So here you can see that number of rows is not equal to number of columns. That is, it is an unbalanced transportation problem. So here is one row is missing. In that row, we have to add another row, the 0 cos. So the new matrix becomes like that. So fifth row, you can see that 0, 0, 0, 0 is here. Like that, if there is one column is missing, you have to another column 0, 0 with the cos. So here in this case, number of rows is less, so we have to add another row, fifth row, like that. Then phase 1, that is row reduction. So row reduction means we have to subtract minimum value from this, like that. So after the row reduction, we have to do the column reduction, the same repeating again, because in this case in the row 0, 0 are the minimum values, then you have to repeat the same matrix as before in the row reduction. So the second step is optimization, that is row scanning. Row scanning means row scanning and corner scanning. So the matrix is like that. Then only one row we are cutting here. Then you have to check all the zeros are covered with the lines, but the square mark is not equal to number of rows because only one row is here. So the lowest element is 4. That is, we have to subtract 4 from each element. Then what we get is like that. Then 1, 2, 4, 2, 0. Then we are doing the row scanning. Is there exactly 1 0 in the first row? Only 1 0 is here. You have to mark with the vertically cutting. And here also the second row only 1 0 is here, vertically cutting. Third row there's only 1 0 because already cut this the element in the third row, block this, but you have to check all the zeros are covered with the lines. No, because 2 zeros are remaining. Then you have to do column scanning. So in the column scanning, after this column scanning, you can see that 1, 2, 3, all zeros are here covered with the lines, but number of squares marked is not equal to the number of rows. So optimization is not reached. So look at the undeleted cell values, take the minimum, that is 1 is the minimum value. So we have to subtract from the undeleted values, and the intersection points we have to add 1, and the deleted value keep it as same. So the next matrix is like this, and do the cross scanning and column scanning. Finally we get this matrix. Then we have to check all the zeros are covered with the lines, and first row 0, 1, 2, 3, 4, 5, which is equal number of rows. So optimization is reached. 1 to 5, 2 to 1, 4 to 2, and 5 to 4. Thank you.